The fifth example states, show that in a right angle triangle, the hypotenuse is the longest side. As you know, the angle sum property denotes that it comes to 180, but it is right angled at B, therefore B can be 90 degrees, and the other two need be found out, and the sum of the other two acute angles, this is acute and this is acute, this is right, and the sum of these acute happens to be 90, because this positive 90, once it goes here it becomes negative, and therefore 180 minus 90 comes to 90. Now the sum of acute happens to be 90. As you can see, this is less than 90 degrees and this is less than 90 degrees, and so this stands to be the highest or the largest angle. The largest angle carries the longest side, therefore obviously this angle takes this side and this angle gives the measure of this side, and this being the longest and the largest and the highest happens to take the longest, therefore hypotenuse happens to be the longest side. The next example, show that all the line segments drawn from a given point not on it, the perpendicular line segment is the shortest. As you know, on a line there can be many line segments from a given point. I can draw many line segments like this, okay, but the line segment which is perpendicular is the shortest. We have to prove this. Now let L be the straight line, this being the straight line, and P not a point not on the line, anywhere not but not on the line, and I have dropped a perpendicular PM and another line, any other line segment which is Pn. From here above, just above, we have proved that hypotenuse happens to be the longest side. Similarly, once the 90 has been established, we know that these three angles make up for 180 by angle sum property of the triangle. Now once again 190 has been established, and the sum of the other two is 90. Just we have seen that in the previous example number 5. Similarly, we have come to know that PM is shortest side and Pn is longer, because this being 90, naturally hypotenuse is the longest side. Now that we have proved that Pn happens to be shorter side, then we can go on to prove that PM is smaller than any other line segment. As you can see, if I take this line, this is a bit longer, this is more longer, and if I go for this is longest. So the longer I move from the center, from the perpendicular area, the line segment becomes longer. So PM is proved to be the shortest of all the lines. Hence PM is the shortest of all the line segments, can be proved in the same fashion as above. Applying this whole property, once again we can prove any line to be longer than PM.